I actually have my dissertation proposal up here. I have my dissertation defense up here, so you can do that as well. And I believe there's even a link to my actual dissertation defense where I'm talking about showing my dissertation defense slides. And then I also have a Twitter link if you would like to actually just click on that for the presentation as well. Now, what I'm going to talk about is innovation in computer science and IT with the utilization of open source software. So being able to take that open source software, couple it with your research, and able to do something, beneficial. So I'll do a quick introduction. I'll talk about or define what open software is, and then we'll go through a number of Linux-based operating systems. Now, there's over 400 distros or distributions of Linux. And there is a distribution that fits for you. Either if you want to deploy it in an office setting, use it for healthcare, engineering, cybersecurity, software assurance, electrical engineering, there are a number of different operating systems that you can actually utilize for deployment. Now, as we talk about Linux-based OSs or desktop OSs, we'll also talk about network-based operating systems as well. We'll talk about like CentOS, we'll talk about Red Hat Enterprise Language, and a few others. And then we'll jump into OSALT, which is open source as an alternative, and SourceForge. And during this particular time, we'll go through the OSALT page and the SourceForge page so you can actually find alternatives to items that you may be doing. So for those who are doing programming, and maybe you're trying to inject malicious code into a program, you can actually go to OSALT or SourceForge, find an open source programming language, and you can use that programming language to still insert malicious code so you can actually save on your expenditures when doing your research. Because a lot of times we have these big, grand, lofty ideas of what we want to do for our dissertation. We say we want to do virtualization, we want to run servers, but all that costs. We have tons of issues with licenses, and if you want to do anything with enterprise architecture, tools such as EA Architect cost approximately $1,200 for a fixed license. Now, if you need a fixed floating license, which means the license floats from one machine to the next, it could be $1,500 and up. And for those who want to do virtualization, you pay per core with VMware ESX. So you're saying, all right, I want to do virtualization for my dissertation research. Now you're constrained by funds, but yet you still want to get this particular job done. So with this open source software, you'll be able to get your research done, spend next to nothing. You just have to spend money on your hardware, which if you're freeing up your costs for your license and stuff like that, you should be able to do that with no problem. We'll jump into virtualization. We'll talk about VMware a little bit, but really more about Oracle VirtualBox. And then we'll jump into Zen Hypervisor. And we'll talk about what hypervisors are, the importance of them, how are they actually deployed in commercial and versus Department of Defense. Then we'll jump into cybersecurity and software assurance. Cybersecurity, more like information assurance, for those who are DSS majors or IA majors. And then we'll jump into software assurance for those who are more involved in writing the code, deploying secure code and stuff like that. And then we'll talk about Linux and K-12 education. This is a really big thing because there's a lot of countries moving towards Linux and actually K-12. And so a lot of countries are constrained with cost. So as their costs are continuing to expand, they're like, okay, well, we have to start cutting costs somehow. And so one of their biggest cost savings is actually moving towards Linux platforms for hosting information, for desktops, for training children and stuff like that. And then we'll talk about Linux and business. A lot of businesses as well are moving towards open source software. The Department of Defense has a mandate which they are pushing to move towards Red Hat Enterprise Language. Ubuntu, they're going to be using now their LTS long-term support for deploying on tactical systems. So you'll see Linux in tanks, you'll see them in UAVs, you'll see them in fixed locations, and you'll see them in tactical locations as well. And then we'll talk about open source in healthcare. Healthcare IT is a huge topic now. There is the strategic operations plan, which is to move all of the medical records online, to share resources between different states, and also to do things internationally as well, and things of that particular nature. So we'll talk about different open source implementations in healthcare. And then last, but not least, we'll have a talk about life beyond your doctorate. Because a lot of times, we say, all right, we're going to get a doctorate degree, we know we're going to get a doctorate, we talk about our dissertation, we defend it, and then at the end of the day, we get a diploma, but we really kind of don't know what we want to do. We say we want to go in academia, don't know how to get there, we say that we want a big promotion at work, may not get there. We have a doctorate, we're happy, right? You get 3 years, you're like, all right, I got everything, I got my diploma hanging on the wall, but yet you're not really reaping the rewards or benefits. And so leaving industry and going to academia, I actually learned a lot about academia and kind of how everything works. So I'll share those experiences, and we'll talk about networking, and we'll do a networking exercise, stuff like that. Because one of the things that we fail to remember, all the people in this room is people that we should be befriending, networking with, making sure we're staying in contact with, because you never know who's going to be where. And I'll give you some examples of that when we talk about life beyond the doctorate. Now again, for those who have to leave early, it's on SlideShare, it's on LinkedIn. If you connect with me on LinkedIn, we can talk via Skype. I travel quite a bit, so when you connect with me, I'll shoot my text, my cell phone number, and then we can talk. All right. So this young man here with the big smile, that's me. I received my doctorate back in 2009, and I started in 2006. I did my master's, my Master's of Science in Management and Information System Security from Colorado Tech Online, and then I did the doctorate, and I went back for an MBA, and I'll explain that when I talk about life beyond the doctorate, and why I went back for an MBA after the doctorate. There's a plan with that. I'm an assistant professor at Alabama A&M University. It's a historically black college or university. We grant all the way up to PhDs. I'm the lead professor of Management Information Systems. We are kicking off a program in information technology management, cybersecurity, homeland security, and intelligence. So I usually post job openings on Moodle. There's 2 computer science job openings right now. One's for a program chair, and one is for a assistant to associate professor. So those jobs are on Moodle, and they're still unfilled at the university. So from time to time I'll post jobs out on Moodle so people can actually view those jobs and stuff like that. I'm also an editor-in-chief of the Journal of Information Systems and Technology Planning. Now, in terms of your research, well, first, how many people here are doing dissertation options? We should see a show of hands. Okay, because everybody's doing all the dissertation. Now, your dissertation is good, it's great. So you finish your dissertation, and then maybe 2 people read it. That's the problem. So when you go, if you're looking for an academic job or a research job, you want to take your dissertation and then you have to turn it into papers. You need to turn it into publishable, peer-reviewed research papers in a journal that is indexed for the type of job or career that you may want. So for instance, if you're going into engineering, you want to look towards journals that are associated with IEEE, the Institute of Electrical and Electronic Engineering. That is an important thing. Because if you just send it to any journal, no-name journal, your publication will be wasted. And then individuals in the research community will say, oh, this is great, you have a nice paper that's in a journal that's really low rated. Because every journal is tiered as far as acceptance and stuff like that. So that affects also kind of the value of your doctorate. So that's another thing that you have to realize when you're doing your doctorate. The journal that you associate yourself with affect kind of the ranking of your research and your value out in the research community. But this journal, we're listed with the bells. For those who are interested in teaching in the School of Business, the top tier accreditation, which is AACSB, is actually, you may have to publish in only journals that are listed with the bells that count for tenure, promotion, stuff like that. So that's a really important thing. I'm also an international advisory board for the Indian Journal of Commerce and Management Studies, and that is also listed with the bells as well. And then aside from that, I've published about over 20 peer-reviewed articles. And then I did about 65 plus peer-reviewed proceedings. And so I started doing my research back in 2010 where I did my first conference. And from there, I made sure I go to conferences a number of times. I worked with a lot of people to actually get publications out, do research, conduct research and stuff like that. And so that's another thing as well. Teaming is a huge, important factor. So Linux. How many people here know about Linux? How many people here use Linux? That's impressive. Usually I get like 4 hands, and the rest are like, what is Linux? I put this poster up here because I thought it was fit for this discussion. Linux is, the way that the GUI, the graphical user interface, looks now is nowhere near as difficult as it used to be, where a lot of items were command line driven, where you have to do your sudo commands, your yum commands, if you're using a different type of package manager. But a lot of people aren't curious or interested in building their cars from scratch. You know, no one goes to the dealership and says, you know what, I want 4 wheels, I want an axle, I may want a radio, I want a windshield, I want to get a body. Nobody does that, right? We all go to the dealership and we say, all right, we want an already made car. So when you think about Mac and Windows, they're pretty much already made cars. All the customization is pretty much done. There's no really changing anything because all the items are proprietary. So you're not going to be able to look into the code. You can't make any changes to the kernel, anything of that particular nature. It's just there, and then you add your additional applications on top of that. Now, for those who are interested in doing hardcore computer science research, actually saying, okay, well, I want to see if there's a covert channel. And a covert channel is a channel that's utilized for a different purpose other than its stated purpose. So you say, I'm looking here for covert channels, or I want to see if I maybe run this in a virtualized environment and I infect it with a virus, what happens? Or maybe I want to see what the source code is because maybe I want to replicate this particular operating system and actually put out something that may be better for the community. You can't do that with Mac, sorry. You can't do that with Windows, but you can do that with Linux. Alright, so this is the abstract that you should see actually on the bio, the sheet. So what motivated me to do this, does anyone here know a guy named Ahmad Al-Saeed? Anybody have class with Ahmad Al-Saeed? Alright. Ahmad is an alumni of Tech, and him and I worked on a book chapter. And our book chapter was called Gaming and Simulation of Higher Education to Retain Students. So it was published with MO Publishing out of the UK. And so our book chapter was the utilization of virtualization and open source software. And what we realized that education costs continue to rise. There are many universities, there's 14 universities in Florida that are begging for money because they're saying that they need state support. In Alabama, even our university is going through financial difficulty in terms of being able to create labs because of all the licensing costs, stuff like that, creating servers because now they have to pay all the associated cost of servers. And then when we talk about implementing cloud solutions are very expensive. It is very expensive how you can implement cloud and stuff like that. So as the cost continues to rise, and not just universities, but K-12 education, we had to come up with an innovative method to provide the same level of learning and cut those particular costs. But the thing is, even though that we're going to change or exchange the actual software, we still have to be able to have students learn and grow. And then for universities, faculty need to do research. It's important. So if you have a faculty member that is doing research on, a particular programming method, object-oriented, and maybe they don't get the resources they need, you still have to be able to say, all right, well, we're going to pull that research that we paid for, that $5,000 software suite, and we're going to replace it with something else. And we're going to replace it with something else that's just as good, if not better. All right, so open source software. If you're able to pull this up, this actual slide has a link in. A lot of the slides have embedded links in them. So the open source initiative has basically defined open source software as free redistribution. What that means is, if I have this particular software downloaded and I use it, I can pass it to anybody, and you can pass it on. So technically, if this was Windows or Mac, and I burned this copy right here and pass it to you, I could potentially go to jail, I could pay tons of fines. But with open source software, I can pass it to you and I don't have to worry about that. You can say, all right, I need a desktop OS or I need a network operating system. I would like to utilize it. I can pull this item out and I can pass it to you. You can use it for yourself or for your organization without any problems. For the other item is source code. The source code has to be publicly available. I have to publish all the source code. And the source code is essentially the code that makes up the actual OS or the actual program or application program. So it's like if you're using Microsoft PowerPoint, you don't really get to see the actual code behind there. But with open source, for it to be open source, they actually have to actually show the source code. What a lot of organizations do, they say they're open source, but they just kind of define the APIs, so maybe you can write code to it or something like that. But for it to be truly open source, you're able to see the entire code that makes up that program. And then with source code, anyone is allowed to modify the source code. The only problem is, if you modify the source code, the entire community has to be able to see that source code as well. So you're like, all right, I got the source code for this operating system, I made modifications, I will repost that source code for the entire community to actually see it and utilize it. Now, as this is used in a defense organization, for defense or for national security, each country is allowed to maintain that source code and not let it out. So if I did modifications to a program that may be secret or top secret or something of that particular nature or classification, that country's government, security agency, maybe the NSA or Communications Electronic Security Group of the United Kingdom, they would just maintain that source code, and then they could decide who they redistribute that to. So in a lot of items that are maybe national security, so it's not a big deal, but it's only used for commercial application or commercial use. The next item is derived words. So this is, you have to show all of the derived modifications. So version 1.1, version 1.2, and then you have to note everything that you changed in there and stuff like that. So basically it's like, if you're familiar with like the capability maturity model, so you have to show traceability, everything that's happened, all the changes, the approved changes, maybe there's a configuration change board that approves all the changes in the software, all that has to be noted. So for the next developer or the group of developers, they can say, all right, well, I'm looking at this particular source code, maybe mode change 1, 2, and 3 items. Okay, should have changed 2 items. I'm going to go back, revert, fix it, get it approved, and put out this new OS. And then the next item is integrity of the author's source code. So for the author who actually built the source code, they get kind of the first initial rights. They can say, hey, I built the source code, and everybody else has got to be adding on to the particular project. And then you have no discrimination against persons or people. So you'll notice that a lot of open source software supports a ton of different languages. And then when you distribute it, you can't make a source code just a program for one group. You can't say, all right, well, I'm going to use this program strictly for Christians, and I can't, give it to Muslims. Everybody has to have the actual source code. There is no discrimination whatsoever. Or you can say, no, I'm a Western country. I built this particular material, but I don't want to give it away to France, or I don't want to give it away to an African country. It's only going to stay in America. That's a no-go. Everyone gets that particular source code. It doesn't matter. There's no discrimination amongst who can actually utilize it or distribute it. And then, of course, no discriminations against different fields. So even though an operating system may be developed for maybe scientific computing, another group can take that same source code and utilize it maybe for virtualization, utilize it for biology or something like that. So the source code should be able to be utilized anywhere. It should be limited to a particular field. You may be building an accounting application, but maybe that accounting application can be utilized in maybe a database. So they can take the source code and port it over to another system. And then distribution of license. Now, distribution of license simply means that a number of people can actually utilize the license. There's not really an issue when utilizing the license. Because for open source software, they really don't make money. They're donations, and all the money comes from services. So with Red Hat Enterprise Language, what they do, the way they make money, they offer services, they offer patch updates and stuff like that. So there are additional services, but if you want to download Red Hat, the first 30 days you get all the patch updates, you get limited support, but after 30 days you don't get anything. So basically you're on your own. You're building your own car. So if you want a patch update, you don't want to pay anybody, you make it yourself. And then one of the other things with open source software in terms of the distribution of license, I can reuse the license multiple times, I can do multiple hostings, and I don't have to worry about getting charged and things like that. And then for the service-oriented service part, usually the service can be done by pretty much anybody, and the license doesn't restrict that. So if you know about Linux or a Linux distribution and you have the know-how, you can create a consulting company and say, all right, I'm an expert in Debian packages. You can come in and actually charge to help somebody out who has a Debian package for a Linux operating system. The next item is the license must not restrict other software. Does anyone here have Windows 8? 1, 2, 3. Have you guys done anything with your Windows 8 system?
Can't stand it. I used it for about 20 minutes, and it was on a desktop. It said, this is a tablet operating system. They're trying to make us use tablet operating system with a PC, and I'm just not going to do it.
Right.
I think touchscreen monitor manufacturers are going to love this because it's really hard to use it if you don't have a touchscreen.
I put it on a desktop, and then I promoted it with a Android tablet using a special app put out by Splashtop that allows it that mimics actually supports the multi-touch gestures. So on the Android tablet remotely through Wi-Fi, you can actually use the touchscreen interface and get a little bit of a better sense of the look and feel of it. But it's definitely one of the full of this part. So a little bit more. I agree. It's the global operating system. So that's really what it has.
All right. Have you guys tried to do anything in particular, such as dual booting or loading any other applications on your particular systems?
Yeah, we had to dual boot with Windows 7. No problem with that.
Other than Windows 7, you try to dual boot with anything else?
Oh yeah, regular XP.
I was discussing with it.
I tried doing it under FreeCap on an iMac and it didn't like it at all, so I had to put it on desktop.
Yeah, there's a huge split in the Linux community right now because Windows 8 is restricting not only the browsers. They're saying, are you going to use Internet Explorer? We all know that's the best browser that's out there. Wink, wink. They're also not letting Red Hat, Fedora, and Ubuntu easy dual booting. For those who have Windows 7, you can actually dual boot very easy using the partition manager. It's like a live partition manager. You just go in there. You don't have to use like gparted or partition magic to dual boot. You simply just go into the live partition manager, choose your partition, the formatting of it, and then you can actually run whatever OS you want. But with Windows 8, they're actually restricting a lot of applications, and especially those are Linux applications as well. And they're actually wanting the Linux community to pay to actually run, to get a license to dual boot and all this other good stuff.
It reminded me very much of Vista and any State Edition.
Yeah.
I don't think it's going to last unless they change it a lot.
Yeah. And with the way that Windows 8 looks, it's really taken from the GNOME 3 environment. So I'll explain GNOME 3 environment as well when we actually run the live disk. But Windows 8 was realizing that a lot of people were liking the new Ubuntu. GNOME 3 environment, the same for SUSE Linux, and the same for Fedora. The GNOME 3 was very crisp in terms of searching and stuff like that. So Windows 8 is like, okay, we're going to come up with a mobile interface as well, but their mobile interface wasn't as good as what was actually done for GNOME 3. But with Linux software and the open source initiative, you can't limit other applications. So what Windows 8 is doing currently in terms of limiting other OSs, other browsers, open source software can't do that. Everything has to be able to run together. You can't download a program and then another program will not run. So that's one of the good things of open source software. You can download a particular program and you can't say, okay, well, maybe my Wi-Fi finder is going to stop working because I'm using another open source Wi-Fi enhancer or something like that. So it's something to think about, especially when you're doing your research and maybe you're trying to do a comparison of tools and stuff like that and you're trying to run them at the same time. Because you could try to say, okay, I'm going to run these particular two virtual systems, two different virtualization software components, and I'm not worried about one cutting off the other because one doesn't allow the other to run at the same time. And you can run a tool that actually captures network traffic and stuff like that, and you don't have to worry about all that stuff. The last item is the license must be technology neutral, which means that the license can't be restricted to a particular technology. For those who have done embedded development, a lot of embedded operating systems and applications are restricted to a particular platform, to a particular processor or a particular hardware group. That particular software is restricted, and it happens quite a bit. So you may buy a particular item and you cannot use it for another OS. There are items that you can probably use on Mac that you can't use on Windows. Mac has a lot of nice editing software for movies and pictures and all that other neat jazz, but if you try to port that over to Windows, it won't work, and vice versa. So the actual items that are implemented to be open source, they have to be technology neutral. So I can take an item from my desktop, use it on my tablet, or I can port it to another platform that may be embedded or smaller, and it still must run. So before Linux, does anybody remember DOS prompt? All right, does anybody remember the command to like change directories and all that other good stuff?
CD backslash?
CD backslash, look at that. All right. So you had to know some type of command, right? So if you wanted to maybe create a document, you had another command for that. If you wanted to copy a document from one system to another system on a network, it is an X-copy command. So you had to understand tons of commands. Well, when Windows came out with the GUI. So they came out with that wonderful GUI. It wasn't that wonderful then. But the GUI allowed individuals to not be as knowledgeable about command prompt and a lot of the back-end stuff. So the GUI puts up a interface that says, okay, I don't have to know about configuring my IPv and command line. I click on this nice utility here. I put in my IP address. I hit apply. I hit OK, and everything's set. And then you had Unix, and Unix was great. But the problem with Unix is very expensive. Unix and Sun Solaris. And then with Sun Solaris, their technology, they're hardware dependent on Spark systems, and Spark systems are thousands of dollars. And so I'll talk about that. I'll talk a little further and explain why kind of Linux kind of came about. So people were looking at a particular Unix-based system that was cheaper to run on a PC. You had a lot of graduate students that wanted to be able to do their research at home. So there were doctoral students at Stanford, and they were at Caltech, and they were like, okay, well, we have the Unix. I have to do all my work in the lab. This doesn't work. I want to be able to do this stuff at home. Well, the students are, if you're a doctoral student and you're only a doctoral student or a graduate student, you're pretty much eating mac and cheese. You got your instant, noodles and all this other good stuff. You're pretty much poor. So for you to actually afford to have a Unix system and run it at home, it's kind of not really something that's going to happen. So what these individuals did with Linux Torvalds out of University of Helsinki was mimic Unix-like capabilities and be able to port it on any type of particular platform. Because, like I said, that was a really big thing. You had this powerful operating system, but it was expensive, and you had to have certain hardware to actually utilize that particular operating system. And so, in terms of proprietary, DOS, Mac, and Unix are all proprietary. And then, this is when you had, so the source code for the kernel is actually protected. So for those who are doing like cybersecurity, software assurance, how can you truly harden a particular item if you can't see the source code? So you have a machine, it's running a particular operating system, and you're saying, okay, I'm going to harden. I'm going to do defense in depth. So you're going to put up a firewall, you're going to put up a router, you're going to make sure, I'll say STIG, which is Security Technical Implementation Guide. You're going to STIG your router, you're going to put up all these parameters, but your operating system has flaws. So you can do defense in depth as much as you want, but if your OS is flawed, that's tons of backdoors, covert channels, and things of that particular nature. The software assurance community has deemed or discovered that over 65% of all vulnerabilities in a network are software-based. Which means if you're unable to truly secure source code or view source code and secure it, you still have 65% of your vulnerabilities open. So yes, you put up a great firewall, maybe you put up strong authentication, two-factor authentication, but if your software is still flawed, you still have openings no matter what. Your network-based item, your network-based security mechanisms will not secure your OS. So it's something to think about. And then the other item was, these individuals want to be able to make modifications without paying high fees. Now, for those who've ever used Sun Solaris, if you don't go from one rev to the next, your fees for getting patch updates, they double. And then if they go to a third rev, they triple. So they keep going, getting higher and higher. So your hardware, they only run on Solaris 6. And they're on like Solaris 10 or 11. And you're like, well, I need to have this hardware for my actual business. I need this, because all my code is built around this particular OS. And so you're like, all right, I need patch updates. I'm like, okay, well, it's going to cost you $4,000 per system. So it does happen. It happened to us in defense. And that was one of the reasons that we got rid of Sun Solaris on a lot of our systems. We had a lot of systems that we were paying $4,000 or $5,000 just for patch updates, just to be compliant for government regs. And so when we moved away from Sun Solaris, we cut out over $100,000 in just licensing fees and patch updates and stuff like that. Because that's one of the things that we tend to forget about, because even with Windows, you may have some applications that will run great on one Windows derivative or distribution, but it may not run great on another. So that's something to think about as well. All right, so the GNU project. This guy right here is kind of king in his own little world. This is Richard Stallman. So there are two communities. There's a freeware community. We all have seen freeware, right? Has anybody here seen freeware? Okay, so you have freeware and then you have open source. So what he wanted to do was define the difference between open source and freeware. So in 1994, he established the GNU project. GNU means GNU, not Unix. That's what GNU stands for. And so basically, he believed that all software should be free. You should be able to modify it, copy it, distribute it without paying anything. So he was the gentleman who was behind the open source initiative. And then we'll jump and talk about Linux for Valve. So basically, GNU, there's a license associated with it, which is called the GNU public license. It's on V3 now. And so this is a license that actually talks about the way that source code can be utilized. Most source code will have the copy of the license attached with it. So at the bottom of the website, it'll say GNU PL V2 or V3. And there's two different variations of the license, and they'll actually have that attached. So when you're actually on a particular website, you're like, okay, is this open source? And they'll say if it's open source or not. But this item, right here on this particular slide, shows just some of the operating systems that actually use the GNU PL. Showing Red Hat, Slackware Linux, Debian Linux, Mandrake Linux, Open Solaris, which is different than Sun Solaris, SUSE, which is a Novell product now. And so these are all items that use the GNU public license. And there's a ton more that we'll see on SourceForge and also open source as an alternative. So the beginning of Linux. So there's a professor named Andrew Tannenbaum who developed Minix. And so Minix was a version of Unix that ran on a PC. Because original Unix would not run on a PC. These are all like supercomputers and stuff like that. So again, if you want to run any type of program at home, not only do you have to be able to pay for the license, for the operating system, but you also have the massive equipment to bring home, and it will not be ported on a PC. So you had Minix. But Minix was for teaching only. It was not intended at all for commercial use. So it was just for a teaching platform to say, all right, this is kind of what Unix is. This is kind of, these are the commands. This is how you maneuver. This is how you write programs, things of that particular nature. And then Linus Torvalds, in his second year as a computer science student at the University of Helsinki in Finland, he came up with the idea of Linux. And Linux became named after him. But it was basically a kernel that would be open source that could be utilized and be ported to OSs for development. So it's kind of a funny thing, and I always like displaying this. So you have the professor, Andrew Tannenbaum, basically says that he would not get it. When Linus Torvalds came up with a design of open source and actually using Linux on PCs and stuff like that, the professor basically was like, yeah, it's a bad idea, it's going to be a big failure, not a good grade that will come of this. Well, Linus actually went ahead and did it anyways. And he didn't do it alone. So with open source, anyone and everyone in a community can actually help out. So that's really how a lot of the actual development is done. So you have universities that have their own software engineers that are teaching computer science students. If you're a professor, you have to get your students, and they can help create an operating system themselves. And so essentially what happened, so what he did, he started off with like 10, 20 people, and since it was out online, everyone was able to help. So they were able to create items like such as GEMP, which is the new image manipulation program, OpenOffice, now LibreOffice, a lot of all the other tool sets that are very similar to Windows and Mac. But this was done with the help of thousands of people. And of course, no one really got paid for it, but again, it's open source and anyone and everyone can utilize it. So it was a community development effort. Now, Linux today. So Linux today is utilized for many computing platforms. You have desktops, you have TVs, you have Androids, PDAs, and a lot of us may not realize that we're using Linux. How many people here have Androids? And do we know what runs on Android? Linux, right? Now, who here has a iPhone? Yeah, I'm trying to get rid of mine, so forgive me. So with iPhone, is anyone here familiar with the term jailbreak at all? Yeah, so if you want to jailbreak a particular iPhone, you have to find a vulnerability within the actual iPhone. So you go into the iPhone and say, all right, there's a vulnerability, there's an exploit in PDF. So now I can unlock my phone and I can do a number of things on my phone. However, I void my agreement with actually Apple. So in terms of if I screw something up, they won't fix it. And then if I do something I should be doing, they'll say, well, we're not going to replace it. Maybe you have to get a whole new phone or something like that. Or they'll find it when I do the updates, or they'll patch it themselves. With actually Android, there's a number of stuff you can do, and you have to worry about that. You can create your own applications and put them on there. In terms of viruses, you're not really worried about viruses as much. You can actually do virtual hosting on your phone. And there are a lot of phones now that are utilized, Androids that are going to be utilized as desktops. So basically carrying desktops, what Androids will be utilized for. I'll show you a kind of picture of that. The other thing is, now you have a ton of commercial vendors that distribute Linux as well. So they'll provide that free code. And then they'll put them in redistributed format. So that's either ISO images, BitTorrents, it's pretty much the item, or they'll have mirrors that are out on the web that you can go out there and you can download that particular software. Alright, so in terms of growing, in 1994 there were less than 1,000 users. In 2006, you can see that there are, well, currently now we have over 29 million users worldwide. So you can see the tremendous trend just in less than 20 years. You can kind of see the tremendous trend and actually the utilization of Linux. Because when you think about the licensing costs, if you're in a third world country or a developing country, you don't have the ability to pay $100 or $400 for an actual license cost. Now, how many of us have traveled outside the States to maybe like either Mexico, Asia, Africa? Has anyone traveled out there and seen? You traveled? Now, when you travel out to these areas and you see that there may be next to nothing, development is pretty poor, you can't expect for these individuals to have the funds to spend $400 maybe on a desktop OS. And then in terms of being innovative and entrepreneur, an organization that's starting out is not going to spend thousands of dollars to get up and started. However, with open source software, Linux has been extremely helpful in actually getting a lot of businesses off the ground, a number of governments as well, getting them able to be efficient in whatever they need to be for their particular mission. Now, one of the reasons that this started growing was because of dot-com failures. So when you had a lot of dot-com failures, and then you had a lot of issues with particular industries because of cost overruns and stuff like that, the number of things people try to do, they try to cut people, they cut training, and then they try to cut technology. So that's what happens anytime a business goes down. So when that happened, there were a lot of individuals who were tech savvy and are saying, okay, well, if we have to get rid of our servers, well, how about we don't get rid of our servers, we just get rid of the actual server OS or network operating system we're using. So then a lot of people started switching OSs. Even Yale went through this recently where now they run pretty much Red Hat and a lot of the servers for Yale University. So a lot of the servers are Red Hat Enterprise Linux. And that was because with the Windows platform they had issues with multi-threading and clustering. And so they couldn't really do that as well as they wanted to. And then of course they had the costs that were associated. Because at Yale they have a lot of professors that are able to remote in for their research. So if you're talking about cloud computing, now you're talking about a location that is maybe offsite or away from yourself or the organization. That's in a server room, and you have your virtualization and cloud software, and you're able to access it from anywhere. So when you talk about VMware and you talk about different types of cores, and you're paying per core, it gets very expensive quick. So now your overall profit is going to drop, and then your ability to get that out to the mass begins to diminish as well. So with Linux, they're able to actually increase the number of servers because when they were getting rid of all their associated license fees, you're able to get rid of all their they were able to decrease their number of licenses that they had to pay for, expand the hardware they had, and continue to put out and continue to support more and more professors. All right, so Linux-based operating systems. Currently, there are more than 400 different distributions out there. There is a website called Distro Watch List. So Distro Watch List is a great resource for downloading operating systems, Linux operating systems. They give you kind of a description of what each Linux operating system does. And even better than that, they have a watch list of all the different Linux operating systems that are to come out. So it shows essentially when it was submitted, who's the project owner. I'll have a page associated so you can see, what fees that they may need help with, if you want to donate or support that OS, or if you want to support by actually helping develop code. Because again, a lot of this stuff is pretty much, I have free time or I'm really involved in this project and I actually want to get this project out. So people may be limited in physical resources where you may have the ability to actually have a class actually write or develop an application. So here I show everything that, like I said, when it was submitted. And you can see there's a pretty long list. The other good thing about this item here, it'll help you get educated on different types of distros, like I said, what they do. So if you click on iOS, I've never heard of iOS. Cloud computing. So now, it takes me to their actual website. Sometimes, like I said, they'll have a page on there that talks about development and stuff like that. And so I can go to iOS, I can download this item, I should be able to use it, and then I should be able to give me a demo or talk about it, and then I can create a live disk. A lot of Linux operating systems have live disks. Live disk is kind of like try it before you buy it. But technically you really don't buy it, but it's try it before you install it. So it's like if you had a PC, a Windows PC, and you want to install Mac, the Mac operating system doesn't allow you to port it, right? If you run it, it installs. With the majority of all the Linux operating systems, you can actually run that particular operating system in a try-me mode. You can search the web, it'll pull up your network adapters, you can create documents, you just can't save anything. So that's one of the good things as well. So if you just want to try it and see how it looks, if you're comfortable with it or get comfortable with it, you can try it for a couple weeks or a month or whatever, then when you're ready, then you just install it to your hard drive.
Dr. Dawson, can you repeat again what this presentation is? I didn't have the pen earlier when you said it.
Oh, it's on slideshare.net and then / Dr. Dawson.
No spaces?
No spaces at all.
Thank you, sir.
No problem. Now, one of the things that you know, there are bugs, just like anywhere else. Now, on slide 15, I'm showing the GNU distribution timeline. And so this GNU distribution timeline outlines items that are either a Debian package manager, they show Slackware Linux. And so when you want to look and really understand all the different distributions and how they came about, this is actually, the link that's on the slide will take you to Wikipedia for this graphic, because you really have to zoom in to really see everything. But you can see everything from 1992 to 2012, and you can see all the different variations. Now, you can even show Linspire, which is a Windows. Does anybody remember Windows at all? Windows was an attempt to get rid of Windows completely. It was a failed attempt. But Windows could actually mimic a Mac It can mimic numerous Windows operating systems and other Linux operating systems, but the back end essentially was Linux. So here you can kind of show you exactly the OS. It shows it has a link to the OS. So you can actually use this to say, okay, I want to look and see what is Windows. You can click here, and it will take you to Windows. Or if you want to see what is Dead CD or Olive or Underground Desktop, you can click on that item as well and get information about it. So this is a good graphic in understanding all the different Linux distributions out there and what they actually offer. All right, Fedora. Now, in the Linux community, everything is done in package. You have different package managers. You have Debian, and you have Red Hat package manager. So basically, this is the items that how they manage the application software itself. So downloading, extracting, and stuff like that. So before there was an issue between different Linux operating systems because there were files that were created for one OS that may not work in another one because of the actual package manager. Even though that the software is free and it's supposed to be utilized on any platform, you just have to go in there and do a lot of manipulation to get it to work on that other platform. Now they have a program called Alien, which is installed in Ubuntu 12.04 long-term support distribution that allows you to utilize any type of package manager with minimal problems. So you can utilize the Red Hat package manager on a Debian package manager system without any issues. So Fedora is basically the bleeding cutting edge version for Red Hat. So Fedora essentially comes out with a release every 6 months. And after 2 years of Fedora releases, those releases become the new Red Hat Linux operating system. So if they're on Red Hat Enterprise Linux 6, that 6, that 6th version that's coming out is 2 years or 4 copies of, or 4 works of, or iterations of Fedora. So if you want to do like cutting edge and maybe graphics or programming, Fedora will have all the items that you want. The problem with cutting edge, it hasn't really been tried and tested throughout, which means there are probably issues, maybe compatibility issues with drivers and stuff like that. So there may be stuff for you to fix, or you to have someone fix. Now, Fedora can be found on the fedoraproject.org. And on this particular project, they will show features. You can actually download it in the community, and then you'll see that it's sponsored by Red Hat. So Red Hat sponsors Fedora, and they sponsor the CentOS, which is the server operating system, because this is more strictly for desktops. And then you have one that is strictly for really servers. But in terms of community, you can actually join a community and help out developing. You can also have students help out in developing. Or you can just join the community so you can understand more about the actual operating system and for networking purposes. Now, one of the things that is great about having the communities, if you have a class of students that have no experience in maybe CMMI, capability maturity model, process engineering, software engineering, and understanding different iterations and stuff like that, how do you manage source code? How do you manage defects? What is really the systematic process of getting the system out? This is a great item because your students could actually get involved for free. And then they could add it on the resume, hey, I helped with the distribution or release of XYZ operating system. And then believe it or not, you get a lot of students that will get picked up by companies such as Google and Windows because your students will actually have that particular background. Say, oh yeah, I've helped out in actually releasing the OS, so I know kind of what stuff needs to go on. Understand, what needs to be done with source code, packaging, and all that other stuff. Because the coding is generally the easiest part. You're plugging away thousands of lines of code, but the hardest part is actually releasing it appropriately. So in terms of releasing it, who takes care of what? They have project managers that are associated with different projects. You have individuals that may be just responsible for developing the Photoshop manager, the Photoshop manager. And so you have a project manager associated with that, and you'll have virtual teams. Because not all your teammates will be in the same place. So basically, you're managing people virtually. You have to motivate them. It's free, right? How do you motivate somebody to do something for nothing? It's kind of like the military. So you have to create a TAC to get individuals to get this work done. And so it's really a big project. We're working on something now where we're adding applications in we're creating what we call hard images for Ubuntu. And so I have students actually, we're creating our program, we have our programming languages in there. We're working on some other apps that we're porting over from Backtrack in our Ubuntu image, and it's a pain. So the students are like, okay, they're great programmers, great engineers, but in terms of the systematic process, it doesn't work that well. Because we have to capture all of our risk and all of our other stuff associated, and then make sure we funnel back up, because we have to respect the original author and what they actually did with the actual program. But again, it's a great learning tool. And then a lot of the sites, they have help. There's free books that you can find. If you just type in Fedora space.pdf, you can actually find a number of free books. There may be a few distros behind, but it's pretty much the same stuff. The content's pretty much the same. So in terms of actually teaching these particular items, you don't really have to worry about it that much. And then also there's a ton of videos out there. There's Mashopedia. If you never heard of Mashopedia, Mashopedia is basically taking like items from YouTube, Wikipedia, they mash them together. So basically they're meshed together, and they're all on a particular website. And you just say, okay, I'm looking for Linux. And so it's a wall scraper, wall crawler, and so it'll wall scrape everything that has Linux tagged with it, and it'll put it in a particular page. Has anybody here seen Mashopedia?
That's great.
Alright, so Mashopedia is a big encyclopedia. I'm going to type in internet. Okay. Now the problem with wall scraping, you pretty much get anything that has internet tag to it or the words tag to it. But you're able to get any, it scrapes Flickr, it scrapes YouTube, it scrapes Wikipedia, it scrapes websites, and it pulls everything that deals or has internet tagged in it. So I type in cryptography. It'll pull everything that has cryptography tagged in it. So if someone has a music video and they call it cryptography, unfortunately that will pop up. But it is a great tool to search a ton of different stuff. So if I go in here and I say, Fedora, I'm learning about Fedora, I want to utilize it for my research. A number of items come up with Fedora. So you have a few videos, people talking about switching from Fedora to Ubuntu. You have the different reviews. And there's a lot of Linux reviews actually out there that you can find on YouTube that you can actually see people who have never used Fedora or a other Linux distribution utilize it, and they'll go through and say, oh, these are kind of the problems. I thought I should click here, I should click here. I need to use some Windows applications. How do I actually do that? Because you can still use Windows applications in Linux. You just have to run a tool called Wine. And I think you have to sometimes have to pay for it, but Ubuntu has it for free. But it's a great help, and it's a great help in any type of research you're doing. So if you're doing anything here dealing with like security, if you're doing enterprise architecture, this is a great place to kind of get some videos and maybe some tutorials and stuff like that, or a particular tool you may be utilizing. One of the cool things that Fedora has is called Fedora Spins. Now, Fedora creates operating systems strictly for a particular purpose. Now, these spins are basically subsets of the larger OS. It's like having a Windows 7 system and then having a Windows Media system. And so strictly you have a Windows OS strictly for managing multimedia content, or a Windows system strictly for doing photography and stuff like that. So with a lot of the Linux distributions that I mentioned, they also count the number of downloads. So if you're kind of iffy about what do I download, what do I utilize, what will be more common, to the right here it'll say what are the top spins or top downloads or top iterations, and you'll see the number of downloads, and they do it weekly, monthly, and etc. So one of the things that they have here that maybe utilize use of people here is they have a security spin. And so the security spin has a ton of tools that you can utilize for doing cybersecurity, software assurance, or other items related to security. You can do threat modeling. You can do forensics. You can do intrusion detection. You can do reconnaissance. You can do web application testing, and you can do a number of wireless testing as well. You can do Bluetooth hats. You can create this as a live disk as well and host it anywhere. And we'll do a demonstration of that here. I have a backtracked disk that I'm going to actually run here. But it's a great tool if you're a DSS or an IA concentration in terms of a tool that you can actually utilize.